Assembling an arbor press is a great example of Onshape mates, as well as the rack-pinion relation. Let's take a look at assembling an arbor press in Onshape. The first step to building this assembly is placing the base. Using the Insert Parts or Assemblies command, I can select the base and select the green check to insert. The next step is to fix the base. Simply right-click the part and select Fix. Now that we've inserted and fixed the base, we can begin adding other components. We can insert other components by going back to the Insert Parts or Assemblies command and selecting the parts you want to insert. You can left-click in the graphics to actually place the part. In this case, I'll place all the parts in the assembly and select the green check to accept. Now that the parts are in the assembly, we can add mates. We'll start by mating the bushing to the base. For this, we'll use a fasten mate. Select Fasten Mate, then choose the mate connector at the end of the bushing and the mate connector at the end of the circular pocket, and the two are mated together. This one fasten mate restricts all degrees of freedom and is the only mate needed to locate this part. We'll do this again to mate the cover plate to the base. Select Fasten Mate, then choose the hole in the cover plate, then the corresponding hole in the base. We can use one last fasten mate to attach the base plate to the base. Remember, you can reorient the primary and secondary axis to correctly orient the part if needed. Next, let's mate the pinion gear to this assembly. For this, we can use the Revolute mate. Select the mate connector at the shoulder of the pinion gear, then choose the mate connector at the top of the hole in the base. Notice the Revolute mate still allows the part to rotate. Now, let's mate the rack gear to the assembly. For this, we'll use a slider mate. Select Slider from the toolbar, then select the center edge mate connector on the rack gear, then select the center edge mate connector on the cover plate. Notice that the slider mate allows for linear travel necessary to accomplish our rack pinion motion. The last step in this assembly is locating the handle to the pinion gear. Again, we can use a slider mate to connect the center of the handle with the center of the hole in the pinion gear. The slider mate will still allow for linear travel, giving the handle realistic motion. Now that we've mated everything together, I'd like to get a realistic rack pinion motion out of this assembly. For this, I'll use the rack pinion relation. Select rack pinion from the toolbar, then select the Revolute mate that locates the pinion gear, and the slider mate that locates the rack gear, then enter a ratio. For this assembly, I want 2.25 inches of linear travel for every rotation of the pinion gear. Now, when I move either the rack or pinion gear, I get realistic movement between them. One last detail to creating realistic motion in this assembly is to limit the range of motion of the rack gear. To do this, edit the slider mate associated with the rack gear by right-clicking on it in the feature list. And then, in the mate dialog, you'll see the option for limits. Simply check limits, then enter the minimum and maximum range of motion. If you're unsure of these, you can drag the part while in the mate dialog, and mate values appear, showing the distance between mate connectors. This is a great way to find the range of motion. After adding a limit, you can see the range of travel the rack gear has is now restricted to the values I entered. I can do this one more time to limit the motion of the handle relative to the pinion gear, and this assembly is complete.